Hello, greetings to you. Welcome to my live broadcasts. Welcome to my live stream. Yes, to you, my live broadcasts. This is online training on solar and inverter installation. So, as usual, please let me know where you're watching from. Please just type in the comment section and let me know where you are watching from. And if you have a question, you drop your questions. But before I start taking your questions, please don't forget to type and let me know where you're watching from. I'm seeing Divine Shaka. Divine Shaka, you're watching from Benin City, that is Edo State. Ude Moses, you're watching from Nigeria. Thanks for joining. Yes, just let me know where you are watching from, and also like the live stream, like the video, like or live broadcast. Thanks for joining. Najes Melki, you're watching from Tunisia. Wow, thanks for joining. Thanks for joining my live broadcast. Edwin Lungu, you're watching from Zambia. Watching from Zambia. Mr. Abraham Messi, you said you have messaged me on WhatsApp as instructed by you, watching from Nigeria or your state. Maybe when I'm through, I will check. Please just send me a reminder on WhatsApp so that when I'm through with the live stream, I will check your message. Mr. Ismail GY, you're watching from Katsina State, Nigeria. Links Technology, you're watching from Ikoyi. You're watching from Ikoyi, you said in Osun State. Thanks all of you for joining. This is a solar panel. The one behind me also is a solar panel. Now, there are a few things, a lot of people are confused or they don't know. If you look at the back of this panel, you can see a small label. Although it's a small panel, this panel is 30 watts. It's a 30 watts panel, and this one I'm using it to charge my solar floodlights. So it's a small solar panel, but the other bigger panels, like the one behind me, is a 200 watts monocrystalline solar panel. So the other bigger panels like 600 watts, but there are specifications at the back here. The data sheet here is always the same. That is the things I'm going to discuss, because a lot of persons are still having issues on how to interpret these things that are written at the back of the solar panel. And if you are a solar installer or you want to be a solar installer, you cannot interpret or make use of the information that is on the data sheet of the manufacturer of any product. And for the solar panel, the data sheet is behind. It's a nameplate, either nameplate, data sheet, specification sheets. Then some of them, at times, they come with a manual like inverter, battery, charge controller. A lot of them, they have their manual. From there, you see the data sheets. So it is very important that you understand the things that are written at the back of this solar panel. Likewise, the charge controller, the inverter, and the battery. It is always important for you to sit down and look at the specifications before choosing, to make use of that, device or component. So if you pick any solar panel, at the back of the solar panel, there are things that are written there. The first one is always Pmax. They will either write Pmax or maximum power. Maximum power. That is the maximum power that the solar panel can generate. the maximum power that the solar panel can generate. It is written there maximum power or Pmax. So during your system design, if you have your total daily energy consumption, you divide by your inverter efficiency, you add both, if you have DC loads, you add them to the AC loads, then you check, you sum up their total daily energy consumption. Then after that, you have to divide by your performance ratio. After dividing by the performance ratio, you now divide by your peak sun hours. Then after dividing by the peak sun hours, you now divide by the total power rating of the solar panel you want to use. So that is where you now look at this panel, the back. You will now choose what is the maximum power of the panel I want to use. For this one, the Pmax, that is the maximum power, is 30 watts. Like I told you, is a small panel. You can see it. It's just a small panel. I'm using it. Is for, what's it called? Solar floodlights. We have solar street lights. We have solar floodlights. So the maximum power is the Pmax. Then you move to the next one, maximum power voltage. The maximum power voltage, or VMP. Either they write VMP or maximum, power voltage. Now, this is the voltage the solar panel will produce when it is connected to a load. When it is connected to a load. Now, you make use of this information if you want to size a PWM charge controller. A PWM charge controller. If you want to size a PWM charge controller, you make use of the total power of your PV array or the total power of your solar panels. Then you divide it by the VMP, or the maximum power voltage of the solar panels you want to use. Then you move to the next one, maximum power current, IMP, maximum power current. Now, this is the current the solar panel will produce when it is connected to a load. Remember, VMP and IMP. These parameters will, you measure them when the solar panel is connected to a load. When you connect it to a charge controller and the charge controller is charging your battery, you connect other DC loads or whatever, the IMP of this solar panel is the current the solar panel will produce when the solar panel is connected to a load. Then you move to the next one, open circuit voltage, VOC. Open voltage, VOC. Now, the open circuit voltage is the voltage that you read from the solar panel when the solar panel is not connected to a load. The VMP, it is when the panel is connected to a load. But the VOC, that is open circuit voltage, the circuit is open. So when you read the voltage, what you have there is a VOC. Now, it is telling you the maximum possible voltage the solar panel can produce based on the specifications I will discuss later. They are down. So I will get, when we get there, I will discuss, I will explain them to you. So the maximum, the open circuit voltage is the voltage you measure when the solar panel is not connected to a load. And you can make use of your digital multimeter. You can make use of your digital multimeter. Remember, the digital multimeter have both, you can measure both DC and AC voltage. You can also measure AC current and DC current. So if you have a digital multimeter and you place the panel on the sun and the panel is not connected to your charge controller yet, the voltage you measure at that time is the VOC. Now, this VOC is very important when you are sizing an MPPT charge controller. MPPT charge controller, you will always see a specification that is written there that the maximum PV input voltage of this charge controller is 150 VDC, 250 VDC, 195 VDC, or 450 VDC, 500 VDC. So if your solar panel, the open circuit voltage of your solar panel is, let's assume it is 41 volts, and the maximum input PV input voltage of that charge controller is 250 volts. Now, if you want to know the number of panels you connect in series to that charge controller, you divide 250 by 41. That's 250 volts divided by 41 volts will give you the number of solar panels you will connect in series to send to that charge controller. Then the next one is the short circuit current, ISC, short circuit current. It is also the current you measure from the solar panel when it is not connected to a load. That is when you short the terminals of the solar panel, the positive and the negative terminal of the solar panel. Let me get my clamp meter and show you. So this is a clamp meter. This is a clamp meter. Now, if you want to measure the short circuit current within the week, I will do a practical video on it. This is a clamp meter. You short, for example, these are the terminals of the solar panel, positive, negative, and positive. So you bridge them, that is, you connect them together. Then you use this clamp meter to clamp on any of the terminal, and it will give you the current. You will do the settings here on the clamp meter. Here you can read AC current, DC current. You see AC voltage, DC voltage. So it's just for you to turn the knob to the position you want to, the parameter you want to measure. So the short circuit current is the maximum current, possible maximum current that the solar panel will be able to produce. Now, you make use of this short circuit current also when you are sizing a PWM charge controller. You can make use of the short circuit current to size your PWM charge controller. Also for hybrid inverters, if you look at the specifications, they will tell you the maximum series current, that is short circuit current. They will give you the maximum PV input voltage and also the maximum PV input current. Some of the hybrid inverters, some they will tell you the maximum PV, that is high voltage inverters. They will tell you the maximum PV voltage is 450 to 500 volts. Then the maximum PV input current is 15 amps, some 20 amps. So you look at the short circuit current of these panels and look at the requirement of the either the hybrid inverter or the charge controller, and when you connect in series. For example, there are some panels that their short circuit current is like 10 amps. So even if you connect 5 of them in series, you will still have 10 amps. So you are still operating below the maximum recommended input current from the solar panels of that hybrid inverter. So you need to stay within the recommendation, the specifications of the manufacturer. Then you move to, okay, that's all. Then maximum system voltage is 1000 volts. Then we have that if you go down, it says test was it here? Okay, test environments. Now, the meaning of this is that all these parameters you're seeing here, there's what we call STC. STC stands for standard test conditions. Standard test conditions. Now, what it means is that these solar panels are produced inside a laboratory under constant conditions. They are exposed to constant conditions. What are those 3 conditions? Number 1 is the irradiance. The irradiance is kept constant at 1000 watts per square meter. If you look at every panel, you will see there 1000 watts per square meter. Then the temperature is 25 degrees Celsius. Then the air mass is 1.5. So in the laboratory, all these parameters are kept constant. So all these specifications you are seeing here, the data you are seeing here, they are at these parameters are given to you based on the STC, that is the standard test condition. But when these panels now come out, They send them to different parts of the world. Now, these panels will face different environmental effects. They will take them to some geographic locations where the temperature is very low or high, where the irradiance is either high or low. So when you expose them to the real world conditions, the real environmental conditions, it will be difficult for this solar panel to maintain these specifications. That is why it is not recommended that when you are sizing a solar panel, you should think in your mind that if like this one now is 30 watts, it will be wrong for me to think that this solar panel will give me 30 watts production from morning till evening. It is wrong. Why? Because the irradiance is fluctuating. It is no longer inside the laboratory where the irradiance is kept at 1000 watt per square meter. So when you bring it out, the irradiance may increase, the irradiance may decrease. So there are fluctuations. The solar panel will not be able to give you that 30 watts output or 100 watt, 600 watt, depending on the size of the solar panel you are using. So that it may produce 100% of its rated capacity. Yes, there's every panels that ideally capacity. So if you take 65%, if during the day the irradiance is high and they produce well, it's still at your benefit. But if the irradiance is low, the number of solar panels you have will still be able to produce the energy that you need. Also, you should know that solar panels have the tendency to produce more than their rated capacity if you give them the irradiance. That is, if the irradiance is higher than 1000 watts per square meter, they can produce more than their rated capacity. There are many that, in fact, good quality panels, like the last one I installed, that's Canadian solar panels. They are producing, at times, if the irradiance is high, they produce above their rated capacity. It's a 605 watts solar panels, but at times they are I think 18 in number, and I connected 9 to one charge controller. So I use 2 charge controllers. Now they are supposed, that's 605 multiplied by 9 per controller is supposed to be about 5000 something watts. That's the maximum production you're expecting. But when the irradiance is high, because of what we call tolerance, the solar panels at times, what I'm reading, what they are producing is up to 6 kilowatts instead of 5 point something kilowatt. They produce up to 6 kilowatts. So solar panels, good quality solar panels, not the fake ones. Good quality solar panels can produce, if the irradiance is high, they can produce more than their rated capacity. So let me attend to a few questions. Thank you all for joining this live stream. Let me see if I can attend to some questions. Or Mr. Ume Obina, you're watching from Asaba. Thanks. Mr. Michael, you're watching from Ibadan, Nigeria. Who again? Ume Obina, please sir, can I use 60 AH to power 12 watts? Is it 12 panel or 12 watt? Mr. Ume Obina, please, can you rephrase your question? Let me know what you, so that I understand what you mean. You're asking, let me look at it again. Where's your question? Okay, please, sir, can I use 60 AH to power? Mr. Abba Abdullahi, you're watching from your disturbing. Network is disturbing. Let me see. Mr. Francis. I'm trying to. Okay, Mr. Rinze. Good evening, sir. How do I know, and if you can recommend anyone for me, eye-size cable for my solar panels installation? There are many good quality batteries. I can't give you any name for here. For now, there are many good quality batteries. Depends on your budget. Though, let me just give you. Depends on your budget. If it is lithium, SRN is there, Felicity is there, Atel is there. Then Mr. Opira Dennis. Good evening, sir.